All right. Well, thank you for being here. I'm Pecinovsky, and I'm going to be talking about how we've or are in the process of introducing accelerated compute capability of Power in the IBM Cloud. And first, I'd like to just say a little bit about myself, my background. I've been with IBM for 22 years, first in network file system, NFS, and SMB, actually, as it connected to iOS. And then after that, moved into more provisioning of Linux. And most recently, for the last 6 years, have been in Power VC, which is private cloud, and doing storage virtualization there. And then this year moved into public cloud, and I'm excited to kind of share the capabilities that are coming out in the near future. About my family, too. We are actually in Rochester, Minnesota. I've got 3 kids at home, and my wife homeschools. We have a big garden, chickens. My wife raises monarchs, and I have about 15 colonies of bees. And they're fascinating to me because if you think about it, they're like a wireless organism. And they thermoregulate their hive, they regulate the carbon dioxide levels, and my only tech foray into this activity has been this year, where I've purchased about a half dozen sensors, so temperature, humidity, and weight sensors, and put those into the hives. And what you see on the lower part here, this green bar, this is the thermal regulation. So they're keeping that brood nest temperature at 94 degrees Fahrenheit, or about 34 degrees Celsius, I think, at constant. Even if it's minus 20 below Fahrenheit outside, they're still gonna regulate that. So, and they're not a warm-blooded creature. So how they do that is interesting. But that's just for fun. That's kind of something I do on the side. What we're going to talk about today here is I'm going to introduce the concept of virtual private cloud for those who are not familiar with it, maybe, and then how we're introducing Power into IBM's public cloud, and then some advantages and use cases. I'll play a demo for you guys and talk a little bit about the upcoming availability and the external a beta program that's going to be starting later this month. And if you're interested in that, come talk to me out. We have a booth here, and I can show more about this at the booth. So this is a busy slide. I'm presenting charts that our offering manager has made up, Elise Spence. She was not able to be here this conference. It did not work for her schedule. And so I'm here instead. I'm a little bit out of my element because when you guys talk about chip design and FPGAs and things like that, that's a little bit removed from my background, but I was kind of fascinated learning about some of the things this morning. So here, this is to kind of level set what I'm not talking about and what I am going to be talking about. So on the left is the traditional workloads, or AIX and IBM I, in the cloud. And there is a separate cloud that's called the co-located cloud for that stuff that came out earlier this year. And that is for the AIX, and it's running on these larger systems, E880s and S922s, and it's kind of narrow-focused. But what I'm talking about here is in the green box, the IBM Virtual Cloud for VPC on Power. So this is natively in the IBM Cloud. So we have AC922s with 2 16-core sockets and up to 1 terabyte of memory in each one. And we've got 4 Linux distros. I think another one is on the way. And this is deployed natively in the same data centers as our x86 hardware. And it's sharing the control plane and things like that. the networking, the fabric. So, and that term there, MZR, that's multi-zone region. So this is where the IBM Cloud is being developed, or it is available in multiple regions, and in multiple zones in each region. So there's a data center for each region. So right now we are in Dallas, Texas. There are 3 data centers there. Those are the 3 zones, which give you the high availability and spread out of your virtual private cloud resources. Future directions, we are looking to expand our public cloud offering to include IBM iOS and AIX, and to give more options there. So kind of bring the blue box into the main cloud in the future. And also, we'd like to provide SSD, local ephemeral storage, to drive the GPU processing even more than what we'll be able to do initially. So we have good performance. I'm not going to cover everything on all of these slides, but one good thing is that the session is being taped, so those that are not here right now should be able to view this later and look at all the slides and the information. So this is a deck that we have been sharing in a few different venues. So what is virtual private cloud? So virtual private cloud is a private network in the public cloud that combines the logical isolation and security of a private cloud with the availability, cost effectiveness, and scalability of the public cloud. This is how we like to say it, and then here's a different way of saying it, that it's a fully virtualized network within the customer's account that gives them fine-grained control of their network traffic through a number of self-managed network services. So kind of like firewalls that they can manage themselves. And the customers, they define their network topology, their subnets in their VPC, and they define they deploy their compute resources, their storage resources, and networking, and it uses a newly developed, developer-friendly API for this, and there's a CLI and UI option, which I'll be showing. So these are the building blocks of a virtual private cloud, and on the left is kind of a schematic. So the big box there is the full IBM cloud that we have available, and where I was talking about before, the different regions within IBM Cloud. So you could have a London-based region, a Tokyo-based region, and within the region then is where you deploy your VPC, virtual private cloud. And then inside that are the different zones, and each zone has their own subnet. These are private subnets, but they can talk to each other with fast interconnects. And on the right-hand side, there are some concepts that I'll touch on here. Public gateway, so that is a resource that you can create and define for your virtual private cloud that allows your VSIs, that's another term that I'm going to be talking about here, that's your virtual server instances, or VMs. So VSI is a VM, but that allows your virtual server instances to talk out to the public internet. And then corresponding to that is the FIP, or floating point resource. You can associate a floating point resource with your VSI instance, and then your instance then you can connect to that instance with that floating point IP. So I can SSH into it using that IP that I've associated, and I'm up and running. I can now, from that instance, connect to any of my other instances using the private network that's there in my virtual private cloud. And there are other services available that you can add in, like VPN, to get a virtual private network, and direct link, which is, I think, a similar concept, but the direct link does allow you to link directly from your virtual private cloud into your own company infrastructure, on-premise networking. So you can go from network to network directly. And there's also load balancing feature and block storage, so you can add in data volumes, block storage to your environment, attach them to your resources. And the one in yellow here is Kubernetes. That's available in the classic part of IBM Cloud today. It's not quite there yet for the next-gen platform that we are deploying Power in, but it will be there soon, I believe. And at the bottom there, the two boxes are the control type of groups or resources I was talking about. One is the security group, and you can associate that on an instance-by-instance basis. And that is going to define your inbound traffic, your outbound traffic rules, what kind of traffic that you're allowing for SSH or ping, et cetera. And similarly for your ACL, that's on an entire subnet that you've defined. And here is kind of a comparison. I don't know what familiarity that you have with the IBM offerings right now, but on the left is kind of our classic software infrastructure. And the API set that we've developed for VPC, for Virtual Private Cloud, is available on that classic infrastructure. That's the middle column there. And it has regions and availability zones. And then the right-hand side is our full next-gen stack. So that's got the revamped hardware stack in it, which includes x86. And then when we have, shortly, the Power, the AC922s will be in there too with 100 gigabit network, et cetera. It said like Z too, that would be a future thing for the Z platform. Here we're on to now the Power virtual servers in the cloud. So this is purpose-built compute architecture to accelerate data in AI workloads. And there's a bit more details on this slide about the dual core, and that they're going to be running in SMT2 mode initially. So you provision your virtual machine, and it's got 2 threads per vCPU. But for a particular workload that you're using maybe for acceleration, you can bump that up to 4 threads per vCPU. And you can only do that with Power. You can't do this on the x86 side. So you have that option with your Power instances. And you can get, for the GPUs, these are the NVIDIA Tesla 100s, and you can get one with either 2 or 4 GPUs. So we've got twice the data bandwidth of other platforms. I won't go through all the statistics here, but one thing I'll call out is 46 times faster Snap machine learning when that was compared to TensorFlow on the Google Cloud. So we're allowing different profiles to be provisioned, and capabilities like multi-home, multi-VNIC, and on the right-hand side is the stock OS options. So we will provide you a set of operating systems, distributions for Linux that you can deploy into your instances. And so these are some of those that are here listed. CentOS, Ubuntu, Debian, RHEL, and later SLES, we hope. And then the profiles, which define how large, what the resources that are going to make up your instance for vCPUs and bandwidth and memory, and that's defined in the profile. And actually, there are slides later that talk to that. So I'm going to cover that more in just a minute. Here's another busy slide with information on more of the services, but really what it's getting at here is that we are in part of the same fabric, 100 gigabit Ethernet fabric, same storage background, same control plane, and we're side by side in the data centers. And so we have the same operational services that you see here for monitoring and metering, SSH keys that you upload to connect to your instances, quotas, and the same KVM virtualization too. So this is not Power VM, this is all on KVM, including on the AC922 Power platform. On the right, yeah, you'll see a picture. I think I have this might be better here. In the data center itself, you can see they're wiring up the racks for power, and then on the left-hand side, they have the covers on, and they're standing a little bit taller than the x86 ones there down the hall next to them. So there's 22 sleds per rack, and 10 have GPUs, 12 without. That's the kind of configuration that we have today. That can, of course, be modified in the future in different regions depending on the use that we get from it. So there are 3 zones per region, and where this is saying there's 56 vCPUs available per sled, per server, that's because 8 of the 64 are reserved for system use. And I'm not going to cover all the stuff on here, but there is an infrastructure type of more capabilities within the infrastructure. One thing I'll mention is like custom images here. Let me go back. You can upload your own custom image to cloud object storage in the IBM Cloud, and you can import that into your environment. And everything is isolated, so the resources that you're creating and importing are just visible to your account. You can see them. You can authorize other users within the cloud platform to see and utilize the resources that you've created. But it is really tied to the account. And so you can import a custom image and then deploy with that custom image as well. There's different connectivity options the VPN is one thing I talked about before, and that they're multi-zone, availability zone. Those are important concepts when you're doing cloud-native applications. So it's the same user experience between x86 and Power. So this is a snapshot of the screen where I'm provisioning a virtual server instance. And towards the top, I'm selecting the image that I'm going to provision. In this case, I'm selecting a drop-down with an Ubuntu image with NVIDIA drivers built into it. So that's going to allow me to choose GPU profiles when I have those NVIDIA drivers in this case. And the next thing I'm choosing is the processor architecture, whether it's standard on the left or Power on the right. And that choice is what gives you what compute resource in the data center. So the Power choice is going to give you the AC922 virtualized resources. And below that, you can see that I've got GPU profiles, and there's a set of them that I can choose from, some with 2 GPUs and some with 4. And the vCPUs and memory and bandwidth that is associated or capped with each of those profiles. So these are significant. The last one there, 56 vCPUs and 448 gigabytes of RAM. That's going to be almost a full. That can be a full AC922, depending on how much memory it's configured with. So we've got, and the UI is going to be the same type of experience. The API as well. Here's more profiles. So we saw in that screenshot GPU profiles. There's also balanced a family of profiles between compute and memory. And there's compute-intensive profiles, which are going to be heavier on the compute side, so they have more vCPU to memory ratio. And then on the lower right is the memory-intensive profiles. So these are going to have a higher memory to compute ratio. And there's actually more of those here. When you see like the P2, that just means generation 2. So everything in this virtual private cloud stack that we're talking about here is called the Gen 2 stack. It's not the classic or soft layer hardware stack infrastructure. And that's what differentiates it, even in the profile names and in different naming that you'll come across in the IBM Cloud. So here MP2 is going to be a memory power profile, second generation, even though power is not in the classic. We're talking about exclusive power capability here in the Gen 2 cloud. So down at the bottom are even more memory intensive type of profiles that you can deploy with. And these are the GPU ones. We kind of already looked at those. This is kind of an exciting slide to be able to share, and I believe Anton is here at the conference, and I believe these numbers came from him or his team in doing a benchmarking or training model exercise, with the large model support. So he's taking on the left in the graphs, the green graph would be the Xeon x86 processors and how well they're doing in pixels per second in this sort of training algorithm. And the only difference between that top picture and the bottom one there is that there's 4 GPUs on the top and 8 on the bottom for the Xeon, for the x86. The power, it's the same. We just have the 4 GPUs on the AC922, and you can see it's 2.85 times faster when it's 4 to 4, and still 2.5 times faster against the 8 GPU x86 solution. And this is the other important point about this is the virtualized versus bare metal. So bare metal is on the far right for the AC922, and there isn't a significant drop in the performance between the bare metal and the virtualized instance that is being compared against in the middle. So when you go to the cloud, this is what you're going to get when you provision a virtualized instance with GPUs associated with it. They come with NVLink 2.0, so that's our GPUs are going to have very fast host to GPU communication with that technology. And the large model support for deep learning enables the seamless use of host and GPU memory for improved performance. Okay, some advantages and use cases. I'm not going to spend a lot of time on these slides. I mean, it depends on if you're more marketing oriented or not. That's what this is going to go through. So in this case, it's the advantages here is you're going to be building apps faster with a better client experience and being able to exploit those GPUs for faster AI insights. And this next slide is similar to that because IBMs, we're really trying to promote these principles with our environments and our offerings, that we're agile, available, secure, affordable. And that's going to be very important for this type of offering as well. When the AC922s, when these virtualized instances are available within VPC, within your virtual private cloud on the IBM Cloud Platform, you're going to see that they're very competitive in their pricing, at or below even the x86 counterparts. So this is going to put it in reach of a lot more individuals and companies than the Power architecture has been in the past. And this is really going to make OpenPOWER architecture much more widely available as people get online and are able to provision these and start using them more for a lot of different applications. So we're targeting clients that want to leverage the GPUs for deep learning, and they want the fastest processing times. We're targeting those customers that want to do, they're going to build their cloud-native applications, from the ground up here. Although as we roll out more functions and features, there's going to be more support for transitioning existing workloads into the cloud too. We're looking for hybrid integration of modern cloud-native services with traditional apps that you have on-prem. And so those are kind of the three areas there. So this is, again, about the V100 GPUs. And that is the type of GPU that we have today, and that's going to be rolled out over the next several months in different regions. And we hope to get different GPU types in the future too. But this one is performing very well for us. And so these are some use cases that they're going through on the slides. So this is one. Here's another one. Building performance sensitive applications, because you've got that wider memory performance. This is going to help with startup costs. And if you're looking, so here's the questions that we ask, or that you can be asking to yourself. Are you looking to provide your internal teams with applications on a more agile environment, faster networking, and you got innovative developers looking to learn new skills? You can put them in our virtual private cloud, get them access to both x86 and Power, because some applications may require x86 instances, and they can talk seamlessly together. You can deploy your multi-node application, and they're all on a private network, very similar to being on-prem. And here's another use case looking to improve the agility of enterprise apps with cloud-native and cloud-based processing, or cloud-based services. So in this case, this user is looking to offload some CapEx expenditures. They're looking to provide their teams applications with a more agile environment and web-facing application. So this will have that. This will be a modern cloud interface. And I will show that in a second here, because I think we're almost to the demo that I will run. This slide is kind of taking the schematic that we looked at before with the region and your virtual private cloud that's deployed into that region across different zones. So I think this is a typo on the slide. I think this should be zone 2, and this is zone 1 over here. And it's showing that you have your secure subnets here, but your VSIs can talk seamlessly together. And there's a private load balancer here that's sitting, a security group here. So this is just a way to visualize the different resources that are associated with your VPC. And there's a floating point IP so that the internet can talk into your instance, and it can talk out to the internet through the public gateway over here. So there's power, and I think what they're trying to show is the x86 instances are sitting here within your virtual private cloud as well. I'm going to move to a demo here. Sorry. I'll try to get this to full screen. And then I'll kind of just pause this as this is playing. Let me move it back to the beginning. So here, Drew has signed into his account, and it's showing him the Gen 1 compute platform versus the Generation 2, and he can choose to work with either one. And he's chosen Generation 2, which is where the power compute is going to be. And in this case, he's creating a virtual private cloud. So he's saying, okay, give me a new virtual private cloud, and he can select on this page a number of things with that virtual private cloud right away as it's created, so he doesn't have to set these things up later. So in this case, he's allowing SSH and ping into his and from his resources, and he's creating a default prefix for each zone. And I'll let this go here a little bit. So if he scrolls down, then he's also saying it went by really fast there, but he's saying to associate a public gateway with this VPC so that he's got outside internet access as well. So I'll let this play again. I think he's already got a VPC, so he's canceling out of that and then returning to the virtual private cloud details here. And then he's clicking on virtual server instances, so he's already got some virtual servers deployed here, some with GPUs that he's named, and they're all in this virtual private cloud that he's created. Some of them have floating point IPs associated with them. And now he's going to create a new instance. So he clicks on that create, and it brings up the new virtual server instance dialog. And this is the screenshot we were looking at before, but he's typed in a name, and now he's picking the image, and he's picking, in this case, the Ubuntu image with the NVIDIA drivers as well. And the radio button here is older. The screenshot I had was newer with the panels that kind of explain more about the compute resources that you're getting. So he's clicking through. Here's x86. He's got these families of profiles, and he changed to the power architecture. And then he's got extra GPU profiles with the power architecture. The high memory, I believe, has been combined with the memory profiles now. So that's another difference between this, when this was recorded, and the screenshot that I had. So he's going to switch to the GPU profiles here, choose one. And then scrolling down, those are kind of the defaults. You can, it's going to give you a subnet by default. It's going to give you your boot volume, but you can attach a data volume to this, and you can create other subnets and associate those with your instances. So we hit create. That came up. It's just a few seconds for that thing to spin up in some cases. And then he's going to the details of it here. So yeah, it shows where it is, the location in Dallas 3. The profile that he used was one for 2 GPUs, 256 gigs of memory, 24 vCPUs. And here's the Ubuntu image that he installed with. And I'm looking for my play options again. I don't know what, there we go. It disappeared. Okay, so he's now bringing up a terminal window. I think he's going to SSH into using the floating point IP that was associated with that instance. So he SSH right into there. And now he's running, or going into the NVIDIA SMIT area. I think he's going to, and showing the GPUs here. So these are the Tesla V100s. They're showing up. And he's going to run a CUDA benchmark. So I'll just pause that there for a second. You can see this is very fast transfer times here. 66, 64 gigabytes between the device and the host, between the GPU and CPU. And now, for the rest of the demo, he's going through Power AI vision use case and selecting a data set. So I think, yeah, this is USGP, so the Grand Prix data set with the cars running around the track. And he's going to run through the association here in a second. So he's capturing a frame, and with the cars that are in the frame or in the picture, and now he's going to make some associations here, I believe, by clicking and dragging these tags to the cars. So I'll let him go through this tagging, and I think he'll run the model. Yeah, so he's going to select here, train the model. And it's off and running, off and training. So he's showing the terminal windows here while that's running. And the thread usage, the memory usage here. And it's just showing it's using the GPUs. And now he's back to the AI vision interface, and is going to run it on his instance, his Power instance that he's been doing this on after it's been trained. So this is just running through that use case, and the video is just showing the cars come in, and then when they get closer in frame here, then it should start automatically tagging them. And this is kind of a popular use case, I think, with sports television, different types of sports, and trying to overlay things and having it be very dynamic and trained to an AI. We get a lot of interest in that. I think that's the end of the demo. Okay. Yeah, so it's got blazing fast machine learning training, which is 3 times faster training and 46 times faster machine learning. That's that number I quoted before when this has been run with these workloads or benchmarks. And it's got faster network speeds for sure and more bandwidth. And this is, it's repeating it. This is kind of the information that I went through before about what your choices are when you're creating these profiles. Okay, so, and we're getting to the end of time here, and I just want to talk about the availability that's tentative. So later this month, we are hoping to enter the external beta phase. And this would be, we're hoping to be a no-charge beta phase. So if you're interested in that, or if you know clients that would be interested in getting and being a part of the beta, you've got a certain use case you want to try out on these Power instances, then let us know. I've got some information where you can give me your information out at the booth, and we can hopefully get some people signed up for that. We've already got a lot of interest, or a lot of people, but we want to make it available to as many as we can, because we're quickly rolling it out. We'll quickly go to a GA phase this year and be rolled into other data centers. So Yeah, this is already talking about a paid beta and GA in December, and then rolling out next year into Washington, London, and other regions. So this is billed on a consumption basis per hour, per gigabyte, and it's very competitive with the other services, Amazon, Google, out there, and within IBM Cloud itself. Power is going to be right there with x86. So you can email me or Elise, our offering manager, to see how you can get into the beta or get using these resources when they're available. Any questions?
I got a microphone. It was on. It was on. There we go. Any questions people want to ask? If not, it is lunchtime, and Carl said he'd be around the booth out. When the booth is available, look for Carl out there if you have interest as well. So thank you very much, Carl. Let's give him a round of applause.
And I can show you more of a live type of demo at the booth. So if you're interested in seeing it more, not just the recorded demo here, I can show you live stuff and we can talk through what's available. But enjoy your lunch.
Yep. Thank you very much. Let's give him a round of applause.